Hello, this is Nischita. I'm making this video as a part of my homework for probability and stochastic processes. This is homework for question 2. The given question says x is uniform in between the values -1 and 1, and we're supposed to find g of x such that y, which is g of x, will gives us the value of fy of y to be 2 into e to the power of minus y into u of y. So we can draw the given f of x as a uniform between -1 and 1, and from the given graph we can note down that the density function for f of x would be half for the interval -1 to 1. In order to find capital Fx of x, we just integrate the given f of x through the limits -infinity to x, which will come up to 0 for x is less than -1, x plus 1 by 2 for x in the interval -1 and 1, and 1 for x greater than 1. So we are given that fy of y is 2 into e to the power of minus y into u of y. So capital Fy of y is again the integration of fy of y through the limits -infinity to y. So on integration we'll find that the value of capital Fy of y will be e to the power of -2y plus 1. So this capital Fy of y is nothing but the probability of capital Y being less than y. So because we know y is g of x, we can just substitute that as probability of g of x being less than y. Now we can find the given g of x equation in two parts. This is an exponential equation. I mean the result is an exponential equation, and g of x can either be an increasing function or a decreasing function. So consider the first probability that g of x is an increasing function. So probability of g of x being less than or equal to y is nothing but probability of x being less than or equal to the inverse function of g of y. So that can be taken as f of x of inverse function of g of y, which is fx of x. So for the we'll just split it into different intervals. So for when x is less than or equal to when x is less than -1, so fy of g of x will needs to be equal to fx of x, which is nothing but on substitution we'll get minus e to the power of -2 g of x plus 1 is equal to 0. So that will come up to g of x will be 0. So for x is less than 1, g of x will be minus half of n log of x plus 1 and by 2. For x is greater than 1, it will come up to 0. E to the power of -2 into g of x will be 0, which means that g of x does not exist for this interval. So similarly, we can just repeat the same steps for g of x as a decreasing function. So here we take p of g of x is less than or equal to y is nothing but p of x is greater than or equal to inverse function of g of y, which comes to 1 minus fx of x. So when x is less than -1 for this interval, again e to the power of -2 into g of x will come to 0. So g of x does not exist in this interval. For x is greater than 1, e to the power of -2 g of x will be 1, which means g of x is 0. So in between -1 and 1, it comes to -1 by 2 log n of x plus 1 by 2. So this can be represented in the equation as g of x is equal to 0 for x is equal to less than -1, -1 by 2 ln of x plus 1 by 2 for -1 to 1, and does not exist for greater than 1 if increasing. And similarly for decreasing, it is 0 for x is greater than 1, -1 by 2 ln of x plus 1 by 2 in between the interval -1 to 1, and does not exist for x is less than -1.